Till now, we have seen several models in which we used trend and seasonality to forecast future sales or revenue. But there was an underlying assumption in all those models. The assumption was that the trend and seasonality do not change over time. But in actual situation, trend and seasonality are constantly changing. Also, in those methods, we gave equal importance to earlier observations and to the latest observations. It might make a better model if we gave more importance to the latest observations to capture trends than to the earlier observations. These shortcomings of the previous methods can be handled by a new method called Winter's method. Winter's method changes the trend and seasonal index estimates during each period. That is, these trends and seasonal indexes are updated regularly, and therefore the estimated forecast has a better chance of being correct. Also, in Winter method, we have the option of giving different weightages to recent and old observation. That is why Winter method is a popular method while forecasting. The key in Winter's method is to use the following three equations, which are used to regularly update the level, trend and seasonality for each time period. To accommodate weightage to old and new observations, we have three new parameters, alpha, beta and gamma, which are called smoothing parameters. The values of these parameters will be chosen to optimize our forecasts. So in these three equations, we are estimating the value of L, T and S. L is the level of series. You can think of it as the base value for that particular time interval if the effect of seasonality and trend is removed from it. T is the trend of the series at that particular time period, and seasonality is the seasonal index for that particular time period or month or quarter. Now if you look at the equation for L, it has two parts. One is alpha multiplied by a term and the other is 1 minus alpha multiplied by the second term. The first part, the first term, is representing the effect of sales in that particular period of time. So it is the most recent observation for that period of time. Whereas the second term is capturing the effect of previous observations. It is multiplication of previous level and previous trend. We are taking a weighted average of these two using the alpha parameter. So the value of alpha will decide how much importance is given to the recent observation and how much importance is given to the older observations. Similar is for trend and seasonality. The first term represents the effect of current observations and the second term represents the effect of older observations. All these three parameters, alpha, beta and gamma, will vary between 0 and 1. So suppose alpha is 0, the effect of recent observations will come out to be 0 for L, and the only effect that will remain is for the older observations. Whereas if alpha is 1, only the effect of recent observation will remain and the older observations will be 0. Same goes with beta and gamma. So depending on where alpha, beta and gamma value remains, the relative importance of recent and older observations will come into the model. This parameter C equals the number of periods in a seasonal cycle. So if you are taking time period of month, C will be 12 months. So it is giving you the number of periods in a seasonal cycle. If you are taking quarters, it will be 4. And this last parameter xt, which is coming in the level and seasonality, this is the actual observed value for that particular time period. So when we go to Excel and apply Winters method, the first step we'll do is initialize the Winter method. By initializing, I mean that we need to find the value of L, T and S for the first observation. So this initial value of L, T and S would be found by the multiplicative model that we did earlier. So for those observations, we will run a normal simple multiplicative model. We'll find out the value of base, trend and seasonality, and that will be our initial value of L, T and S. Once we have that initialization value, we will use that and update the value of level, trend and seasonality for the next time period. And we will continue to do that for all the time periods that we have in our data. Alpha, beta and gamma will be our variable cells. We will use solver to change these cells and get minimum squared error on the forecast. The final alpha, beta, gamma value that we get, for which we are getting the least sum of squared error, that we will use to predict future sales. So see you in the next video, in which we will apply the Winters method. In this video, we are going to learn how to implement Winters method for forecasting. I have a data of month-wise airline miles traveled by customers from January 2003 to April 2012, and we are going to forecast the airline miles that people will be traveling for the next 8 months. As told in the theory lecture, for Winter method, we need to initialize the value of level, that is base, trend and seasonal index. These three values will be initialized using the multiplicative model. So we will use the first 2 years data to build this multiplicative model to get the value of trend and seasonality. So in this sheet, which is titled Initial, I have run the multiplicative model and established the trend and seasonality value for the 12 months. If you have any doubt on how to run a multiplicative model, you can revisit our video on multiplicative models. Now I have copied the value of trend and seasonality from that sheet into this Winter sheet. These are the initial values. For base, I am going to deseasonalize the actual value by dividing it by the seasonal index. So the base value is 40.34, trend is 1.006, and these are the seasonal indexes. Now I am going to use these three equations to predict the value of L, T and S for the next observation. In this process, my trend and seasonal index will be updated. Then I will use the updated indexes to further get the updated values of L, T and S. The alpha, beta and gamma are going to be our variable cells. These are the cells that we will be changing using our solver, and we'll try to minimize the error from the forecast. So the process we are going to follow is this. We'll first find out the updated value of base using this LT equation. Once we have the updated value of base, we'll then move on to find the updated value of trend, and then we'll find out the updated value of seasonality. When we have all these three values, we will multiply them, that is, we will multiply base with trend with seasonality to get the forecast for next time period. So base, trend and seasonality of time period T will give me the forecast for time period T plus 1. We'll find out the difference between forecasted value and the actual value. We'll put it here. We'll square that error and we'll add all these squared errors into this cell. This sum of squared errors we'll be minimizing using the solver by changing these values of alpha, beta and gamma. Once that optimization is reached and we have the value of alpha, beta and gamma, we'll be using the last value of L, T and seasonality to forecast the values for the coming months. So if the concept is clear, let's start writing the formulas. First is calculating the base value, which is equal to alpha times, within bracket we will write actual value xt divided by seasonality of previous time period. Since this is January 2005, we are going to see the seasonality in January 2004. This is the first term plus 1 minus alpha times LT minus 1, which is the base value of previous time period, multiplied by the trend of previous time period. We'll put dollar symbols in front of these variables so that when I drag them down, they do not change. So all these 13th row variables will be getting the dollar symbols, and this formula is ready. So the base for next time period is coming out to be 40.30. Similarly, we will find out the new trend. So it is beta times new base by previous base plus 1 minus beta times previous trend. Again, we'll put dollar symbols for these 13th row cells. Now we will predict the seasonality index for the month of January is gamma times actual value by base value plus 1 minus gamma times the previous seasonality index for the same time period. So for January 2004, the seasonality index was this. The forecast is going to be the product of base, trend and seasonality index for the previous time period. So base and trend of December and the seasonality of the month of January. This was the forecasted value. The error is going to be forecast minus actual. Squared error is square of this, and we will select all these cells and double click on the bottom right corner. So till the last row of this table, we have the values of base, trend, seasonality, forecast and squared errors. Now we are going to get sum of squared errors in this cell. So it is sum and all these values. So now we'll be minimizing the sum of squared errors given by this blue cell by changing these colored variable cells. So we'll open solver now. In the objective cell, we will say H24. We have to minimize this cell by changing alpha, beta and gamma. we'll put a condition that alpha, beta and gamma will stay between 0 and 1. So the first is these three are less than equal to 1 and these three are greater than equal to 0. This is as covered in the theory lecture, that alpha, beta and gamma range between 0 and 1. The unconstrained variables are non-negative. That is also given by the constraint that we have added above. So we do not need to take this, but even if you take it, it does not make any difference. Click on solve and we have our solution. So the value of alpha, beta and gamma is coming out to be 0.54, 0.05 and 0.588. Now for our model, we have the value of alpha, beta and gamma. We have the last value of base, trend and seasonality. Using these values, we are going to forecast the values for the coming 8 months. So the forecast for the month of May 2012 is going to be the base of April 2012 multiplied by trend raised to the power the time interval after this base. So since this is the first time interval, we raise it to the power 1. If it is the second time interval, so if we are forecasting for June, this power will be 2. This multiplied by the seasonality index of May in 2011. So this 1.03 value. We'll put dollar symbols for level and trend, since those will remain same when we drag down this forecast formula, but seasonality and the time interval will be changing, so we will not put dollar symbols there. Hit enter. This is the forecast value. Drag it down for the other months and there we go. Here we have the forecast sales value for the next coming 8 months. If you want to get the total sales, you can just add them up. So in the coming 8 months, how many total units you are going to sell, you can just get that by adding these up. So I'll summarize the whole process of implementing Winter's method. We have data for airline miles traveled. You may be having it for sales or revenue of different months. Using first few months, we will apply the multiplicative model and find the initial values of base, trend and seasonality. Using those initial values of base, trend and seasonality, we will forecast for the next period and we will be updating the new values of base, trend and seasonality for each time period. The forecast will be done on these updated values only. We'll then run solver to find out the optimum values of alpha, beta and gamma, for which we get the minimum error between forecast and the actual values. Once we have optimized the model and we have received the values of alpha, beta and gamma, we'll go and check the last value of base, trend and the final values of seasonality. Using those values, we'll be forecasting for the future months. For forecasting for future months, we'll be using the normal multiplicative model in which we multiply base, trend and seasonality effects. This is how Winter's method accommodates changing trend and changing seasonality and gives us better prediction for future sales. Till now, we have been discussing forecasting sales given previous data of the same product. But a lot of times we are launching new products or product based on new technologies. In such scenarios, it is very important to forecast future sales for several years once the product has been launched in the market. It is observed that for a new product, the sales graph over time looks like the letter S. Therefore, it is often referred to as S curve. So if a product's sales follow an S curve, then up to a certain point, sales increase at an increasing rate, and beyond that point, the growth of sales slows down. So in this video, we are going to learn how to use S curve to estimate the sales growth rate and maximum sales from early product sales. So this is how an S curve looks like. On the x-axis, we have time intervals. So it starts at some point, our new product is going to be launched. On the y-axis, we have cumulative data of sales or revenue. When I plot the sales data against time, usually for new products, this S type of curve is observed, where the rate of growth increases in the beginning and then decreases after a certain point. This point in the middle, where rate of growth is 0, is called inflection point. So using few data points of product sales, if a marketing analyst is able to draw this S curve, the marketing analyst can find out two important information points from this curve for the new product. The first point is the upper limit of sales. That is the maximum quantity of sales that you can generate using your new product or product based on new technology. The second is the inflection point. That is the time period at which the rate of sales will change from increasing to decreasing. I hope you understand the difference between this new product forecasting and the forecasting we have been doing till now. If we consider the forecasting we have been doing till now, for the marketing analyst, we would probably be having data for January, February, March. Using the data for these 3-4 months, if we forecast for other months, that would give a straight line which will be increasing at a very high rate. For example, if you consider mobile phone sales, in the initial few years when this technology was new, the rate of growth was increasing and a lot of people were buying new phones. But slowly, over the period of time, when this technology is not that new, the rate of growth in sales of phone is not as high. So eventually, the sales of phone is going to saturate at a certain point. This is what this S curve is capturing, and from this curve we are going to find out these two important points, the upper limit of sales and the point at which the rate of growth is going to change from increasing to decreasing. Now to model the S shape for product sales, we can use different mathematical functions. There are two most popular functions. One is logistic function and one is called Gompertz function. We'll be using these two functions to model the S shape for our product sales. The first is the logistic function, which is also called Pearl function. This function is represented by this formula, in which the cumulative sales or the percentage of population adopting the product or sales per capita, whichever variable you want to estimate, is xt. L is the upper limit of sales divided by 1 plus a e raised to power minus bt. Here t is the time period, a, b are some constants. So if we assume this kind of relationship for our product sales over time, this will give us a S-shaped curve. So using solver, we will use previous data of xt and t to find out the value of L, A and B. Once we have the optimum values of L, A and B, we will use them to forecast future sales using this model, and all these sales value will overall create an S curve. The most important value that we will take away from this equation is the value of L. L is going to tell us the maximum value of sales or of sales per capita or percentage of population adopting our product. That is, L will be setting the upper limit of this variable. So using this equation, we'll be applying logistic curve to model the product sales. The other is Gompertz curve. To create a Gompertz curve, the equation is this. Xt can be any variable for which you want to forecast. It can be sales, it can be revenue, it can be cumulative sales. T is the time period, and A, B and C are three constants which we are going to estimate using the Excel solver. Once we have the value of A, B and C, we can forecast future values. Here, the upper limit for variable xt is going to be A. In the next video, we will see how to model logistic curve, and then we will also see how to model Gompertz curve. But when do we use which? If the likelihood of future adoption is based on the prior adoption, then we use logistic curve or the Pearl curve. But if there is no relationship between number of people buying in future basis the number of people who have bought in the past, then we use Gompertz curve. So if Facebook is trying to predict how many maximum people will be using their platform in the future, they will probably use the logistic curve, because how many people are going to use in the future largely depends on how many people are actually using it now and in the past. But if you have a situation where the new adopters are not much influenced by the old adopters, then we use Gompertz curve. So let us see how to model logistic curve to forecast new product sales. Building this model is exactly similar to what we have been doing till now. We have this equation of xt. We have to use this equation to forecast a value. We'll find out the difference of this forecasted value and the actual value in this cell. We will square it, add all the squared errors in this cell. We will try to minimize this value by changing the values of L, A and B. Once the model is optimized by Excel solver, we will have a value of L, A and B. L will be the upper limit of the product sales or sales revenue, whatever is your X variable. Here I have the percentage adoption of cell phones in a group of customers yearly. So in the first year, 15% of that group adopted cell phones. In 2002, 19% of people had adopted. In 2003, 22% and so on. So till 2011, 86% of the people had adopted cell phones. Now if I model this to be of logistic curve, I'll use this value of year. This is the first year. In this T, I'll use the value of L, A and B. These are the initializing values, and I'll calculate the corresponding forecast for the first year. So I'll write the formula here is equal to L by 1 plus A multiplied by e raised to the power, which you can get using this exponential function, e raised to the power minus b into t. So minus b multiplied by this first time period. We'll have to put dollar symbols for this third row variables. And the formula is ready. We will press enter, and this is the forecasted value using these initial values of L, A and B. I'll just drag it down for the other years to get the forecasted values. In this cell I'll get the squared errors and I'll square them power 2, drag it down. In the sum of squared errors we will add all these squared errors. So the model is ready. We just need to minimize this sum of squared errors by changing the value of L, A and B. So the objective cell is H3. We want to minimize this by changing the variable cells, these colored 3 cells. Now we'll be adding constraints. In this particular problem, when we are using GRG nonlinear solving method, in the options you have to go and tick multi-start. So this is a multi-start GRG nonlinear method. When we are using a GRG multi-start method, we have to specify the upper and lower limits of all the variables. So we have 3 variables L, A and B. For these 3 we'll have to specify constraints on upper and lower limits. So first is all these 3 are positive. A and B are less than 1000. We have used the number 1000 because we wanted to use a big number. We do not know anything about A and B. If the actual value of A and B is coming out to be close to 1000, we will go and increase this limit. Otherwise, if they are very small, we do not need to change this limit. Lastly, I'll put an upper limit of 200 just because we think that it is unlikely that we'll have 200 cell phones per 100 people. You can have a different constraint as per your business requirement. Okay. Now we'll click on solve. And this is the solution that we get, where L is coming out to be 118 nearly, A is 11, B is 0.31. Since A and B values are not nearly 1000, these are very small values, we do not need to change the constraint for A and B. Even for L, the value is significantly far away from 200, so we do not need to change any constraint. Now that we have the values of L, A and B, we can predict or forecast the values for the coming 3 years. So you can see for 12th year we'll have adoption of 94%, in 13th year we'll have 99.9%. If you want to plot this graph, just select these 2 columns, go to insert and select a line chart. So you can see this has a slightly S-shaped curve. Which is the logistic curve. The value of L, which is 118, is giving us the maximum adoption for our group. That is, at max there will be 1.18 mobile per person in that group. The second thing that we can take away from this graph is the inflection point. Inflection point, as you remember, we defined as the point where the growth in the graph changed from increasing to decreasing. It is some point near this 7 or 8 time period, but if you want to get the exact time period when the growth will start to decrease, it can be calculated by using the formula ln A by B. Note that it is not ln of A by B, it is ln of A, this whole term divided by B. I am getting an inflection point of 7.67. This means that after nearly 7.5 years, the growth will start to decline. Many companies try to find the inflection point and use it as a target time till which they can use this as a growth product. Until this time, they have to come up with a new product so that they can continue overall company sales using that new product. Since after this time period, their existing product is going to get a decline in sales. So this is how we used logistic curve to plot the S curve for new product sales. In the next video, we will see how to use Gompertz curve to plot this S curve for new product sales. In this video, we are going to use Gompertz curve to fit the S curve for new product sales. Gompertz curve is given by this equation where xt is equal to a into e raised to power minus c raised to the power minus bt. We have the values of t in the first column. We have three variables a, b and c. By changing the value of a, b and c, we'll try to get the best forecast, that is the forecast with least sum of squared errors. The process is same. We'll just use this formula to calculate the forecast and then we'll minimize sum of squared errors. So we'll start typing is equal to a multiplied with exponential minus c times another exponential minus b times t. T is the value in first column. Put dollar symbols so that when we drag it down, these reference cells do not change, and we can press enter. So using those initializing values, we are getting these forecasts. We'll find out the squared errors. Drag it down. Add all these squared errors to get sum of squares. And the model is ready. We just need to use the solver. We'll minimize sum of squared errors by changing these three cells. Now again we are going to use the multi-start GRG nonlinear solving method. So we need to give the upper and lower limits of a, b and c. So we'll add those constraints that a, b and c will be greater than or equal to 0 and a, b and c will be less than or equal to some value 1000. This 1000 is just a big number. If any of the a, b or c value is coming nearly 1000, we'll be increasing this threshold. Go to the options, GRG nonlinear, and select use multi-start. Now the model is ready. Just click on OK and see the solution. So here is the solution. A is coming out to be 209, B is 0.12 and C is 3.21. Now using these optimized values of A, B and C, we can predict the values of future sales just by dragging down that formula. So for the 12th, 13th and 14th here, it is going to be 97.9%, 106.7% and 115%. If you want to plot this also, just select these two columns, go to insert and select a line chart. You can see that it looks more of a increasing line chart. It does not look like an S-shaped curve, but since the upper limit that this curve is giving is 209, this curve is going to curve after a much larger time period. So over a large period of time, this will look like an S curve. You can see that there is significant difference in the upper limit given by logistic curve and the Gompertz curve. So it is very important that you look at your business scenario. If the product sales are going to be impacted by the old product sales, then use logistic curve to model the forecast sales. If the new product sales does not depend on old product sales, then you can use the Gompertz curve. When we discussed new product forecasting using the S curve, we needed little data to plot the S curve using the logistic or the Gompertz function. Now, if we have no data, that is, this product is exactly new, there is no other product, and it is going to be launched for the first time in the market, in such a scenario, Bayes diffusion model can be used successfully to forecast future product sales. This model also gives the analyst an explanation of how the knowledge of new product spreads throughout the marketplace. The Bayes model is based on the concept that the diffusion of new product is driven by two types of people. One is innovators, that is the first adopters. These people seek new products without caring about what the other people have to say about that product. The other type is imitators. Imitators are people who wait for other people to try the product first. If they give a good review for it, only then they use that product. So the Bayes model helps the marketing analyst determine the relative importance of innovators and imitators in driving the spread of that particular product. The Bayes model asserts the following equation. In this equation, the small n t is for product sales during that particular period. This is the value that we want to predict. Capital N T is the cumulative product sales till that period. So it is sum of sales of product in all the individual time periods till time t. N bar is the total number of customers in the market, and we have an assumption that all of them are eventually going to adopt our product. So this is the eventual number of customers that we are going to get with our product. P is the coefficient of innovation and Q is the coefficient of imitation. If you look at this equation, there are two components in it. The first component, which is n bar minus n of t minus 1 period. This is basically telling us the number of people who have not yet adopted the product. Since n bar is the total number of customers who will be taking our product, n t minus 1 is the cumulative customers till t minus 1 period who have bought our product. So this difference is telling us the number of customers who have not yet bought the product. In this term, there is no influence of the people who have already bought the product. So this term is independent of the number of people who have already adopted the product. This term is multiplied by P, which is the coefficient of innovation or external influence. That is, these people are the innovators and we are multiplying their effect with a parameter P, and the value of P will determine what is the importance of innovators for our product. The second component has the interaction between previous adopters, which is given by n into t minus 1. These are the people who have already adopted the product, and the people who are yet to adopt. So that is the same n bar minus n into t minus 1. This interaction is to capture the effect of adopters on the non-adopters. This part is multiplied with the coefficient of imitation, and this is capturing the imitator's effect. The imitation factor is often also called network effect. So for any new product, sales in any particular time period can be predicted using this formula. In this formula, we need to identify four factors. One is P, one is Q, One is the total number of customers in the market, customers who want to buy our product, and the cumulative sales till the previous period. We want to know these four factors, then we can forecast the sales for the coming period. So how do we find out the values of those four parameters when the product is completely new to the market? We do not have any historical data to help us out here. So we follow 3 steps to find out the value of these 4 parameters so that we can forecast future sales. The first step is to estimate the first year sales by sampling and surveying. Once you have created a new product, collect a sample of people, ask them the question that how many of them would like to buy that product, how many of them can afford that product, and so on. The agenda of this survey would be to find answers to these 4 questions. What is your total market size? What proportion of customers out of this population intends to buy your product? What is the proportion of customers who can afford the product? And what is the proportion of customers who will get the access to the product in the first year? Once you have identified all these 4 factors, as published in a paper by Bayes, you can calculate the first year sales using this formula. In this formula, S is for the first year sales. S is equal to total market size or the total population for which you conducted this survey multiplied by the proportion of customers who intend to buy. This is given by I multiplied by this one factor which includes the effect of customers who can afford it and customers who will get the access to the product in first year. By putting the values of T, I, A and C which you estimated from your survey, you can get the estimated value of first year sales. The next step is to identify analogous product. Analogous product is a product which belongs to the same category or has similar features to the product you are offering. The point of finding this analogous product is to estimate the distribution of innovators and imitators for our new product. We are going to assume that for that similar product, the distribution of imitators and innovators will be same for our new product. If we take this assumption, we can use the value of P and Q which we calculate for that analogous product as the P and Q values for our product. Now we have the value of P and Q, we have the value of first year sales. With using these 3 parameters, we can use the Excel's goal seek tool to estimate the value of N bar, that is the total market size for our product. This is the total customers who are going to buy our product in the lifetime of the product. When we have all these 4 values, our Bayes diffusion model is ready. We can forecast value for any time period using that model. So in this video, we are going to learn the implementation of Bayes model to forecast new product sales. Suppose you work in a company which has now just invented smartphones. Till now, people have been using feature phones with keypads. Now your company is bringing about touch-based smartphones. And as the marketing manager for that firm, it is your responsibility to find out forecast of how many units of product your company is going to sell. Now you decide to forecast the sales of this product using the Bayes model. As told in the theory lecture, you can implement a Bayes model in a 3-step process. The first step is that you go to the market and conduct a sample survey. The agenda of this sample survey would be to gather these 4 information points. First is what is the total target population. Out of them, how many of the people intend to buy your product, how many of them can afford your product, and how many of them will get access to that product within the first year of its launch. The first three you can find out by doing a sample survey. The fourth is something you have to decide with your production and distribution manager. Once you have established the value of these 4 parameters, you can estimate the first year sales using this formula proposed by Base. And if you put the values of these four parameters in this formula, we get an estimated first year sales value of 1.32 million. So out of 95 million total population, you are expecting to sell 1.32 million units of your product in the first year. This was the first step. Now let's move on to the second step. In the second step, we have to find out an analogous product, a product for which the behavior of customer is similar. That is, the proportion of innovators and imitators will be similar. For your touch-based smartphone product, you think that the proportion of innovators and imitators will be similar to the feature phone. So you find out the sales data of feature phones from the time it was launched. So in this table, we have the sales data of feature phones in the first 16 years of its launch. Using this, we will fit a base model and find out the value of P, Q and N bar, for which we get the minimum sum of squared error. We know how to do this. We have been doing it throughout the course. Let's apply this formula in this column, and then we will find out the difference between forecasted and actual. We'll find out the square of this difference and add it in this sum of squares cell. We'll use the solver to minimize it. So let's write the formula. First we'll find out the cumulative sale. This is sale of this term plus cumulative sale of the previous term. So it is equal to previous term cumulative sales plus sale of this term. You can extend this formula till the last cell and we have the cumulative sales for each period. Now to predict the value, we'll write this base model formula is equal to P multiplied by N bar minus cumulative sales in the previous period plus Q by N bar times N bar times N bar minus cumulative sales of previous period again multiplied by cumulative sales of previous period. Now we will put dollar symbols at the appropriate location. So all the cells in the third row will get dollar symbol. So here is the predicted sales value using these initializing values of P, Q and N bar and applying the base model formula. Corresponding to this predicted and actual value, we are going to find out the squared error. Extend it to all the other cells. And in the cell above we will find out the sum of squared errors. Now our model is ready. We just need to use the solver to minimize the objective cell F2 by changing these three cells with the constraint that all these three values are going to be greater than equal to 0, and P and Q are less than equal to 1. And we will give an upper limit to n bar, which is going to be some random big number, and we'll click on OK. In GRG nonlinear options, we have to take this use multi-start option and click on OK. So we have the solution. These are the optimized value of P, Q and N bar for this analogous product, for which we are getting minimum sum of squared error. Assuming that the behavior of innovators and imitators is going to be same for our new product, we are going to use the same value of P and Q for our new product. So we'll copy this and we'll move on to, and we paste the values of P and Q in this third step. In the third step, we are going to use the P and Q values of the analogous product. We are going to use the predicted first year sales from the step 1, and we are going to find out the value of N bar, for which the predicted first year sales come out to be this value, which we found out using our survey. So what we are going to do is we are going to create a table which will have month-wise sales, because we want to take into account the customers who buy the product in the first month will have an impact on the number of units being sold in the second month. So we'll be predicting monthly sales of our product using the base model. If you want to be more precise and do not want it to be month based, you can even do it on day basis. So using the value of this P, Q and some initialized value of N bar, I am going to predict the actual monthly values of sale. Then for the first 12 months, the sum of total units sold should be equal to the predicted first year sales. Once we have the monthly units sold, the sum of units sold in the first 12 months should be equal to the predicted first year sales. So we are going to use Excel's goal seek tool to equate the sum of these 12 to this by changing the value of N bar. When we do this, we will get the actual value of N bar instead of this initialized value. And once we have the actual value of N bar, our model is complete. We can predict or forecast the sales value for any time period for our new product. So let us find out the first month sales for our product. So this first time interval is before the launch of the product, so it is 0, 0. Once the product is launched, in the first time period, that is in the first month, we are going to sell P into N bar minus previous time period's cumulative sale plus Q by N bar multiplied with N bar minus previous month's cumulative multiplied with previous month's cumulative sale. This is for the whole year, since we estimated the value of P and Q using the yearly data of analogous product, so we'll divide it by 12 to get monthly sales. We'll also put dollar symbols for these P, Q and N bar values. And press enter. The cumulative value is going to be the sum of previous cumulative plus this time period's actual sale. We'll extend it for the first 12 time periods. Here we have the predicted sales value in this column for the first 12 months. Now, since our predicted sales value are in a different scale and the first year predicted sales value is in a different scale, we'll change the predicted sale value by scaling it down and dividing it by 1 million. Now we are going to use the Excel's goal seek tool to find out the value of N bar at which this cumulative first year sale is equal to that predicted first year sale. So we'll go to data. In the what if analysis, there is goal seek. We want to set cell this cumulative sales cell to this first year sales which is 1.318448 by changing cell this N bar. Let's click on OK, and here we have it. You can see that the sales for first year is coming out to be 1.31 now, and the value of N bar is coming out to be 24.8, which is in millions. So the estimated total customer base throughout the product's lifetime is 24.8 million customers. Now the model is ready. You just need to extend that to other months. If you look at the last cell, it is giving you the cumulative sales till the 4th year of that product's life cycle. So till the 4th year you would have sold that product to 6.2 million customers. So considering that we had a total population of 95 million in the first step, we are selling it to nearly 6.2 million customers in the 4 years. We can say that in the first 4 years we'll be selling to 6% of the total population. This is how, using information of analogous product, gathering some information from the market by doing sample surveys and applying base model on this collected information, we can estimate the sales for a new product which is getting launched in the market for the first time. Hello everyone. In this lecture, we will cover some of the basic mathematical functions in Excel. But before that, let us understand the small difference between formulas and functions in Excel. Most people use it interchangeably, but there is a small difference between the two. A formula is an expression which calculates the value of a cell. It can be any expression. What we wrote in the last class were mathematical formulas such as is equal to a1 plus b1. A function is a predefined formula. Functions allow you to use descriptive names to automatically apply formulas for you. For example, sum, average, etc. are functions. We will see how to use them. We use functions because they increase user productivity when working with Excel. So I hope the difference is clear. Anything that is calculated in a cell is a formula, but functions are predefined formulas of Excel with descriptive names. Now let's see some of the mathematical functions we use in Excel. Let's first look at the data we have. In this data, we have scores of 5 students in 3 subjects: Maths, Science and English. We want to find out the total marks scored by these students. For this, we can simply write the formula as earlier using the plus symbols, or we can use the sum function. Let's use the sum function this time. We go to the cell and start typing is equal to SUM, start the bracket. Within the bracket, a function takes parameters on which it operates. For example, for the sum function, we need to give all the numbers which we want to add. There are 2 ways to enter these numbers. One is to enter each cell individually separated by a comma. Let's do it this way for this row. First cell, comma, second cell, comma, the third cell. Close the bracket, hit enter, and this is the sum of these 3 numbers. If you click that cell again, in the formula bar you can see the function applied. Instead of using cell reference, you could write the value of the cell also, like sum 95, 83, 81. That would give you the same result. But as discussed in the last lecture, using cell reference has some benefits. For the student 2, we will use the second method. Instead of entering each individual cell, I am going to select the whole series this time. We start again with is equal to sum. Within bracket, we use the mouse to select the entire range of cells that we want to add. Close the bracket and hit enter. Let's compare the difference between these 2 formulas in the formula bar. In the first formula, you can see that the 3 cells are separated by commas. In the second formula, only the endpoints of the series are written and between them is a colon. So this represents that everything between M6 and O6 is to be added. Can you see the power of sum function over the normal addition formula using plus symbols? If I have to add 100 numbers, I do not need to write the cell reference of 100 cells. Just select the entire series within a sum function. Now for the third student, I want you to notice another feature of Excel. When in a cell we type is equal to, Excel expects that we are going to enter a function and it automatically starts recommending functions as we type the first few alphabets of the function name. If you do not want the function, do not bother, just continue typing. But if you want the suggested function, press the tab key. It will auto complete the function as well as it will start the bracket for you. Lastly, to calculate for other students, we will simply drag the formula by going to the bottom right corner and extending it to other students. Using any function is similar to this. Just type the name of the function, give the parameters in the bracket and hit enter. That's it. Let's cover other mathematical functions quickly now. Next, we look at the min function, which returns the minimum value from the input data. So to get the minimum score in maths, we go to this cell and start typing is equal to min tab. When we hit tab, this function will be selected. In the parameters, we need to select the range of cells. So these 5 were the score of students in maths. We close the bracket and hit enter. You can see that 45 is the minimum score scored by any student in maths. We can extend this formula for science and English also. So 53 is the minimum score in science and 55 is the minimum score in English. Next, we look at the max function. Max function returns the maximum value from the input data. So to get maximum value of score in maths, we go to this cell and write is equal to max. If you want to select the second formula here, you can use the arrow key to go to second and then press tab. Now we need to give the series from which we have to select the maximum score. You can see that 99 is the maximum marks in maths. We can extend it for science and English also. Next is the average function. This function returns the average or the mean value of the input numbers. If you remember, in the last lecture, we calculated average using usual mathematical operators. This time we use the function. So to find average marks of each student, go to this cell, type is equal to average. When Excel suggests average function, you can hit the tab key. After this, select the range of cells for which you want to calculate the average. Press enter. Drag to get the average for other students. Once we have calculated the average marks, we may want to assign ranks to students also, as to which student scored the highest marks and who scored the least. To rank the students basis their average score, go to the next cell, type is equal to rank average. The first parameter is the number whose rank you want to find. This will be the score of the student. The second parameter in this function is the series from which rank is to be calculated. So this will be the scores of all the students. The last parameter is how should the ranking be done, whether highest should be ranked 1 or lowest should be ranked 1. If you want highest to be ranked 1, such as the case here, the third parameter will be 0. For the other scenario, it will be 1. So we enter 0 and press enter. You can see that the average score of student 1 makes the student 1 second in class. Important thing to note here is, if we drag this formula down, the reference cell range will change. So the reference cell range changes from P5 to P9 to P6 to P10. P6 to P10 is not the correct reference range. In the last lecture, we discussed how to maintain the reference range. To lock the reference range, we need to use dollar signs. To do this, go to the reference values and add dollar symbols. There is a shortcut for adding dollar symbols also. Just click on the cell on which you want to add dollar symbols and press F4. Dollar symbols will be added to both row and column name. This will restrain reference values to change while dragging. So now let's extend it for other students. Now you can see that the reference cell remains from P5 to P9 and student 4 is now at rank 1 and student 5 is the student with least average marks. Next we move on to sum product formula. In this formula we input 2 or more series of numbers and it returns the sum of product of individual elements of these two series of numbers. For example, if we want to assign weightage to the marks of maths, science and English of these students before calculating their ranks, we have written the relative weightage of each subject here. Now I want to find the total marks as per weightage. That is, I want to find the sum of 95 into 2 plus 83 into 1 plus 81 into 1.3. This will be the total marks for student 1. To do this, we go to the cell and type is equal to sum product. Then we select the first series of numbers, comma, select the second series of numbers and press enter. We get a value of 378.3. This is calculated by adding 95 into 2 plus 83 into 1 plus 81 into 1.3. This can be dragged down, but before dragging it, remember to use dollar symbols for the weightages. We can drag this down now. And here we have the total marks of students as per the weightage. Next we look at rand function. Rand function is used to generate random value between 0 and 1. This is an amazing function. It takes no input parameter. It just generates a number between 0 and 1 randomly. But why do we need random numbers? Random numbers can be used to simulate chance events like throwing a dice or tossing a coin. For example, say we want to randomly select a class monitor or a class representative out of these 5 students. I will generate one random number for each student. Whoever gets the largest number becomes class rep. So we go to this cell and type is equal to RAND. Hit enter. You can see a random value is generated for student 1. We can drag it down for all the students. We can see that student 5 has the maximum value and now student 5 can be selected as the class representative. Next we move to rand between function. This will return random value between the range that we have provided. So this function takes two values as inputs and generates a random number between these two numbers. In our example, for student 6, we can randomly assign marks for maths by going to this cell and typing is equal to rand between. and giving the range as 40 and 100. This student has scored 56 marks in maths. We can extend this to science and English also. You can see that every time you change any cell, the value of rand and rand between gets refreshed. So now this student has scored 88 in maths, 42 in science and 77 in English. Let's see this one more time. If I add any value to a new cell and press enter, these values are refreshed. Basically, doing any operation in the Excel sheet triggers a refreshing of these values. To stop this from happening, we can use the paste as value technique. So the thing is that these cells contain formulas, whereas we are interested in the value already generated by these formulas. The formulas have already served their purpose. So what we do is we copy the contents of these cells. The content of the cell is a formula. You can see that by pasting it in any other cell. You can see in the formula bar, when I paste it, it still contains the formula. But we want to keep the value and not the formula. So we copy the cells and paste them here as values. This is the option for pasting as values. This comes only when you have copied a formula. It basically gives the option to copy paste a formula as a formula or the value calculated by the formula. Now, as I have pasted the values, I have the randomly generated values with me, which won't refresh every time I perform any operation. There are several other mathematical formulas, such as the ones in this sheet. We encourage you to try these on your own. You can also find a list of all the formulas in the Excel menu. Click on the Formulas tab and select Maths and Trigonometry. Here you can see the list of all the math related functions. That's all for this lecture. See you in the next one. Hello everyone. In this lecture, we will cover some of the most important textual functions. Textual functions are used to perform operations on the text type of data. For example, if we need to remove any particular word from a group of words, or if we need to extract first 5 or last 5 characters of any word, for such operations we need to use textual functions. So let's get started with the first textual function. Here you can see we have student 1 pre-entered in the first column, and you can notice that there are unwanted extra spaces in front of it. Similarly, the second and third student 1 values have extra spaces either in between or in the end of the text string. To correct this, either we can edit each one of these text strings or we can use a simple trim function. Trim function removes extra spaces from the text string. It will remove spaces from the beginning or at the end or even between two words also. Let's look at our example. In this cell, there are extra spaces in the front of string student1. Using trim, we will remove these extra spaces. using trim function is very similar to using other mathematical formulas. First, to start the function, we have to type is equal to. Then we will mention the function name, that is trim. And after that, we will mention the text string we want to correct. And press enter. You can see extra spaces are removed. Now let's move on to the next example. You can see extra spaces between student and the numeric 1. Again, we will use trim function to remove these extra spaces. We will follow the same steps. And now you can see that there is only one space between the word student and numeric character 1. Trim function has removed the extra spaces which were present between these two words. Now for the third row, you can see that there are extra spaces at the end of the string. Again, we use trim function. We can simply drag the function from above. And now the extra spaces at the end are removed. However, these cells contain formula instead of the required string. To get string, we know what we have to do. We use the copy and paste as values technique. These cells now have actual string values with no extra spaces. Now let's move on to the next function. Suppose I have two strings in two cells. Let's say first cell contains first name and second cell contains last name. Now how do we combine these two strings to create a full name? For such situations, we can use concatenate function to combine the two strings. Let's first try to combine English, math and science. As always, we will start our formula with equal to symbol. Then we write concatenate. You can see that in this cell we have all the three strings joined together. First comes maths, then without any space comes the next string which is science, and then comes the third string which is English. To further understand the use of this function, let us try to create a table where instead of just marks, we will write that student 1 has scored so many marks in this subject. To do this, we go to the cell and type concatenate. Select student 1 cell, comma, write the script between double quotation marks, space has scored, space, comma, select the marks from table 1, comma. Now again enter the script in double quotation marks, space in maths. When I press enter, you can see that the complete sentence is created. Student 1 has scored 95 in maths. You can see in the formula bar, concatenate function is taking student 1 from this cell, has scored is an input by us, marks is coming from the upper table, and then there is another string which is an input from our side. Now to extend this for other students, you can simply double click on the bottom right corner and the entire column will be filled. You can see for student 5 also, the entire string is correct. Student 5 has scored 45 in maths. Concatenation can also be done using ampersand symbol. Ampersand is the symbol that we see on the numeric key 7 on our keyboard, and it looks like this. This is also the and symbol that we use while writing text. So now in the English column, we will apply the ampersand symbol to get this same result. To do this, select student 1 cell, type ampersand, enter the string within double quotation marks, has scored, ampersand again, marks within double quotation marks in English. You can see that ampersand performs the same operation as concatenate function. In concatenation, it's like a normal function where you first mention the function and then give all the strings as parameters. In ampersand, it is like using plus symbol. You write the string, add an ampersand, you write another string, add an ampersand, write another string, and so on. Next up is substitute function. It is used to substitute a particular string with another string in the selected text. For example, to rectify the spelling of student, we type is equal to substitute, select the text in which you want to change the strings, comma, input the part of the string that you want to replace. Always remember to put double quotation marks while mentioning strings. We want to change B to D. So the third parameter is what you want it to be changed. You can see the text student is now student. Same thing can be done in sentences also. For second row of the table, we can update the score in the sentence from 38 to 95. So student 1 scored 95 marks in science. In the third row, we can change the text science to English. Important thing to note here is the word science is case sensitive. If you make the S of science small, it will not be able to recognize the same. You can also note in the formula column, we have written the formulas, but these formulas are not returning the values. In this cell, you can still see the formula written. To do this, we have used a single space in front of the equal to symbol. It is because of this space, Excel is not calculating the actual value of this formula and showing this whole thing as a text in the cells. If I remove the space and enter, you can see that the formula will be calculated and the value of formula will be shown. So in this way, if you want to show the formula to someone without calculating the value, you can just add a single space in front of the equal to symbol. Next is the upper and lower function. These functions simply convert the entire input string to upper or lower case. For this, we type is equal to upper and select the string. You can see that student1 string is now completely in uppercase. In the next cell, we will use lower. And you can notice that the S of the student, which was earlier uppercase, is now lowercase. To completely fill the table, we select both the cells, go to the bottom right corner and double click, and the entire table is filled. After this, we look at the length function. Length function returns the length of the input string, that is, it returns the count of characters including spaces in the string. So for example, in the first cell we have student1 written. Student contains 7 characters, then there is a space, and then there is a numeric 1. Total it contains 9 characters. So we will now use the length function to see how many characters does this actually have. Len, and then we select this string. You can see that this length function returns the number of characters including the space in between. We can extend it for the other strings. You can see that the next string length is 11. You can manually check if Excel is giving us the correct answers. The last set of functions we are going to discuss are left, right and mid. Left function will help us select a particular count of characters in the string from the left. In this table, we have QR code values which consist of 3 different parts. One is the year of manufacturing, which are the first 4 characters of the QR code. The last 2 characters are the group of that product, and in between there are 5 characters which represent the product ID of that particular product. To segregate these 3 parts from the given QR code, we first use the left function. To apply left function, we start typing left, select the string, comma, type 4. This will return the first 4 characters of the selected string. You can see that the first 4 strings, that is 2018, is returned by the left function. Right does the same thing. It just starts the counting from the end of the string. For example, here we want to get the right 2 characters of the string. So we type right, we select the string and then type 2. You can see the right 2 characters have been returned. Mid is like left. Only difference is that you can change the starting point for the count. For example, if you want the 5th to 9th characters from this QR code, you type mid, select the string, give the starting point, which is the 5th character, and then give the number of characters. Here we want 5 characters. you can see that the middle 5 characters are returned by this mid function. We can select these 3 cells and double click on the bottom right corner to complete this table. Like I told you in the previous lecture, all the textual functions can also be found in the Formulas tab of the Excel menu. I would recommend that you go and explore these other textual functions also. That's all for this lecture. See you in the next one. Hello everyone. In this lecture, we will cover important logical functions. We begin by discussing the logical test on single argument, that is, if one particular condition is true or false. Single argument test can be implemented very easily by just typing is equal to, select the cell and apply the condition. In this case, we want to identify if any student has scored 100 in maths or not. So we type is equal to, select the cell, is equal to 100. Extend this for other cells. We see outcome is true for only one student, the student 4 who has scored 100 in maths. When we have 2 or more arguments, two situations arise. Either we want to check that all arguments are true or not, or we want to check if any one or more of the arguments passed is true or not. If all arguments are to be true, we use AND statement. For example, if we want to identify students who have distinction, that is they have scored 75 in all the 3 subjects, we will use is equal to and enter all the 3 conditions separated by commas. Extend it. We can see that 3 students have more than 75 marks in all the 3 subjects. If we want to check truthfulness of any one or more of the arguments, we use OR. For example, if we want to identify students who have failed in any one or more of the subjects, we use is equal to OR and enter the 3 arguments. We extend it. We can see that only one of the student has failed because that student scored 30 in English, which is less than 35. Let's move on to the next formula, which is the if formula. This formula uses the outcome of the logical test that we discussed previously and gives predefined outputs for true and false outcomes. For example, if we want to assign grade to students basis their math score, where students with equal to or more than 75 marks in maths has grade A, else has grade B. We do this by typing is equal to if the logical test output if true, output if false. Extend it for other students also. If we want to do multiple logical tests in sequential format, we can use nested ifs. Nested if means that within one if statement, you use another if statement which will be called basis the output of first if. It will be easier to understand this using an example. Here, if we want to grade students as A if score is more than equal to 85, B if score is between 60 and 85, and C if score is less than 60, our first if will check if it is more than 85. If true, we write grade A. If false, our second if, which is the nested if, will check if it is less than 60 or not. If it is less than 60, then grade C, else grade B. We can further have more ifs if we want to have more checks, such as to introduce grade D, we can further have another check of 40 marks. Try to do that yourself. We can also have and or within the if statement if we want to check several conditions at the same time. In the previous sheet, we used and or, which was giving us true or false as outcome. Now, using if, we can have particular output to these outcomes. If true, we want to output pass with distinction, else nothing. So let's apply this formula. Passed with distinction. For or, we will have if true, output will be failed, else we will have promoted to next class. So we'll write or the three conditions: English less than 35, science less than 35, maths less than 35. If true, failed, else promoted to next class. Extended for other students also. The last student 5 has failed. All the other 4 students have been promoted to next class. Next we move on to COUNTIF function. Although this is part of statistical formulas in the formulas menu, but we will discuss it with the logical if formula only due to its similarity with a function. COUNTIF returns the count of cells which satisfy the given criteria. Here, if we want to identify number of students who have scored grade A, B or C in every subject, we type is equal to COUNTIF, then select the range, comma, mention the criteria, enter, extend it for other grades also. So whenever maths grade matches with A, it counts it as 1. So we have 3 students with grade A, 2 with grade B and no one with grade C. Similar operation can be done on other subjects. Remember to put $sign appropriately before extending the formula. You can refer our previous lecture to see how to put $signs in the formulas before extending them. If you want to have multiple checks while counting, count ifs can be used. To implement count ifs, we type is equal to count ifs, first range, first criteria, then second range, second criteria, and so on. So to get the count of students with distinction, we use countifs as follows: is equal to countifs m5 to m9, select the criteria, then the second range, select the criteria, then the third range, select the criteria, enter. The advantage of using countifs is just by changing the value in this cell, which is the criteria cell of 75, we can change the criteria of classification of distinction or not. We can see that no student has scored more than 90 marks in all the three subjects. However, COUNTIFs only gives us the count. It does not tell you which student has actually passed with distinction, which we found out earlier using the if statement. Next up is SUMIF formula. This is also not part of logical formulas per se, it is under mathematical formulas, but let's cover this also with if and COUNTIF. SUMIF is similar to COUNTIF, the only difference is that it will add the cells which satisfy the criteria instead of just counting them. For example, if we want to find sum of marks of students in maths who have not failed, we start by typing is equal to SUMIF. First select the criteria range, which is the fail column. Then specify criteria, which is if false. Then specify the range, sum range, it is the math score of the students. This has returned 349 as result, which is sum of math scores of students who have passed the class. That is the first four students, 99 plus 65 plus 85 plus 100, which is 349. Similarly, you can find this for other subjects also to fill this table. Like we discussed COUNTIFs, I would encourage you to explore SUMIFs on your own now. That's all for this lecture. In the next lecture, we would discuss the date time formulas. Thanks. Hello everyone. In this lecture, we will be covering date and time related functions in Excel. We all mention date and time in different formats. Sometimes we use date, month and year, which is DDMMYY, or sometimes it is month, date, year, MMDDYY, or sometimes the month is written in words instead of number. Excel supports all these formats and it even identifies the input in cells if those are dates or not. For example, if I type 1 oct and press enter, it picks up that it is date automatically, and in the formula bar it is written in default date format. One function which we will use to see today's date in default format is equal to today function. This just returns the today's date. Whenever the sheet is refreshed, this formula is also refreshed. So this is showing 12th November right now, but if I close the sheet and open it tomorrow, it will show 13th November. Similar is the now function. We type is equal to now, tab, enter. You can see this includes the time also along with the date. Important thing to know here is, although Excel is showing us date, time in readable formats, in the back it maintains dates and times in number format. If we change this date to number format, we can see that it is converted to a real number. The integer part of this number is actually the count of days from 1st Jan 1900. So for 1st Jan 1900, the value will be 1. For 30th December 1900, this value will be 365. Today is 12th November 2018, which is 43,416 days from 1st Jan 1900. The decimal part denotes the time. So 24 hours will be 1 unit. For 12 hours, it will be 12 by 24 into 1 is equal to 0.5. For 6 hours, it will be 6 by 24, which is 0.25. Right now, it is 4:32 p.m., which is 16 hours 32 minutes, which is coming out to be 0.69. Now we will see some common date time formats available in Excel. For this date, if we want it in some other format, right click on this cell and select format cell. In the category menu, we can select date to look at different date formats. We can select time in the category menu to look at different time formats. We can also create a custom format Go to type, click on custom, go to type field and mention the format. For date, we write DD. For month, if we want complete month, type MMMM. For year, YY, and then time as H colon MM. Enter. We can see that the date time value is now shown in the desired format. Next, we look at day, month, and year formulas. For any particular date, we can separate different parts of it using these formulas. So to get which day of the month it is, type day and select the date. Today is 12th day of November, so 12 is the solution. To get the count of month in an year, use is equal to month and select the date. November is the 11th month, so we are getting 11 as the answer. Similarly, to get year, type is equal to year and select the date. We are getting 2018 in this. Important operations that we usually need to do on date time values involve finding the number of days between two dates or finding time difference between two timestamps. To find the number of days between two dates, you can use is equal to days and select the dates. This returns the number of days between the two dates selected. We can see that between 12th November and 1st November there is a difference of 11 days. Similarly, for the next case there is a difference of 440 days. You can also do this by simply subtracting the two dates. You can see it is giving us the same result. You can figure out why this works by recalling that dates in Excel are kept in number format and difference of those numbers in integers is the number of days they are apart. To get this difference in hours, multiply this value with 24. To get it in minutes, further multiply it with 60. Third way to find difference in the two dates is the datediff function. This function allows you to specify what you want in return, whether you want difference in days, months or years. For days, we type is equal to datediff, start date, comma end date, comma D for days, M for months and Y for years. So you can see that in the second row, there is a difference of 15 months between the two dates selected. Similarly, it can be done for getting the difference in years. That's all for this lecture. In the next lecture, we will discuss the index, match, and lookup functions. Thanks. Hi everyone. In this lecture, we will learn how to apply lookup functions, index, and match functions. First is the lookup function, which stands for vertical lookup. This function will search the value that we specify vertically in a table and then return another value corresponding to that value from the table. I know that the definition is not very clear, so let us look at this example to understand this clearly. Suppose in the small group of 5 students that we have been studying, we want to add the music scores for these students from the music teacher's table. The music teacher has other students in the list also. The task of matching each student and assigning marks will be very cumbersome if we have a lot of students. This is where VLOOKUP will help us. To use VLOOKUP, type is equal to VLOOKUP, select the value we want to match, then select the table which is to be referred, then mention the column number from which we want this response. This is the second column. We want response from second column which contains marks. The fourth parameter is the type of match we want. If we want exact match, this should be 0. For approximate match, this should be 1. We want an exact match for student 1 value in the table, so we will use 0. Press enter. We see that it went to the table selected. It matched the lookup value vertically to student 1 here. It gave back the value in column 2, which is 45, as we have asked it to do. Now we put dollar signs on the reference table values and extend the formula to get music marks for other students. Next is HLOOKUP function, which is horizontal lookup. In this, the value will be looked up horizontally in the table. We will give the row number from which we want the response instead of column number. For example, if we want to add to our table marks of students 6 in maths, science and English from another table which contains marks of students in all the subjects, we will type is equal to HLOOKUP, select the subject name, then select the reference table, press F4 to log the reference table values, comma, then give the row number which is 2 in our case, 0 for exact match. Extend it to fill the table. We can do the same for student 7 also, only the row number will be 3 instead of 2. Please try that on your own. Next we will look at the index function. As the name suggests, if in any given table we want to access any particular value whose index number or the row and column numbers are known to us, we use the index function. In this example, if we want to find the score of a particular student in a particular subject, we will first translate the student number to a row number, then translate subject name to column number, and then use it in index function. This will be the reference table for our index function. You can see that student number actually can be used as row number. So student 1, the 1 of student 1 is actually the row 1 of our table, and so on. For columns, maths marks are in column 1, science are in column 2 and English is in column 3. So we note down 1, 2 and 3 over maths, science and English. This conversion we can do by using nested ifs as discussed previously. Now we apply index is equal to index, select the table, give row number, comma, give column number, press enter. So you can see that first student has scored 99 marks in maths. If you change the number of student to 2, it will be updated to 65. If you change subject to science, it will be updated to 53. You can try changing different values of students and subjects to get different marks as output. Next up is match function. Match function will return the position of a particular value in an array. That is, if you have a list of 10 numbers, match will tell you the position of a particular number in that list. So here, if you want to find the student who has scored maximum marks in each subject, we first find the maximum marks scored in each subject using the max function. Now we will use match function to find the position of this maximum value in the reference list. So we type is equal to match, select the cell and then select the array. Press enter. This max value is the fourth value in the list, which also corresponds to student 4. Similarly, you apply match function horizontally to identify the subject in which each student has scored the maximum score. Again, we find the max score using max function. We then match this max value with the table selected horizontally to get the position. Here position 1 represents math, 2 represents science and 3 represents English. For student 1, max marks are achieved in maths. Next we look at how we can use a combination of index and match in place of VLOOKUP or HLOOKUP. Usually we do not need to do this for small data sets. But if you have a large data set, VLOOKUP will take up a lot of processing power of Excel. You may have to wait for very long time to get the result. You may have to look at messages which say Excel is not responding, etc. A lighter way to achieve the same objective will be to use index and match combination. In this combination, index will return the value desired from the table and match will help us identify the row number or the column number of the table from which the value is to be returned. For example, if you want music marks of student 1, we start typing is equal to index, tab, select the reference table. Note that in the table below, the column in which value is to be matched need not be column 1. This can be any column in index match. However, for VLOOKUP, the reference column should always be the first column. The second parameter is row number, which will be returned by match function. So we type match, select student 1, then select the array below, comma 0 for exact match, close the bracket, comma, column number which will be 1, enter. This gives us the same result as VLOOKUP, only this is quicker than VLOOKUP. Put $sign appropriately and extend to other cells. That's all for this lecture where we covered an important set of lookup formulas. In next lecture, we will look at data sorting, filtering and few other data tools. Thanks. Hi everyone. In this lecture, we will learn about some important set of data tools, tools that will make your data more meaningful and help you get more information out of your data. The first tool is data sort. This helps arrange the data in a particular order. If your data has text, it will help order it alphabetically or in reverse alphabetic order. If it contains numbers, you can arrange them from smallest to largest or from largest to smallest. Let us apply data sorting on this table. First, select the column you want to sort with. I want to arrange them according to their marks in maths in descending order. That is, the highest scorer should be first. So select maths column, go to filter and sort in home menu. You can also find this option in data menu. Select sort and filter. Select sort largest to smallest. You see the option of either expanding the selection or continuing with same selection. If we continue with same selection, students will stay in the same order, that is student 1, student 2 and so on, but their marks will be sorted. This will assign wrong marks to the same student. Let's try this once. You can see that now student 1 has scored 100 marks whereas earlier student 1 had scored some other marks in maths. We will undo this. Do Ctrl Z. We will use the option of expanding the selection while sorting. So go to sort largest to smallest, continue, expand the selection, sort. Now we can see that student 4 who actually scored 100 marks is now on top, whereas student 5 who scored the lowest is now at the bottom. We can similarly sort from smallest to largest. We will sort student basis their English marks from lowest to highest. Let's do it. we can see student 5 is now in first row with lowest marks and student 1 is in last row with highest marks. To do alphabetical ordering, we select the table below, go to sort and filter, click on sort A to Z. The table is sorted alphabetically basis the content in first column. To sort from Z to A, select the other option. You can see that the order is reversed. In this first table, when we sort students basis their maths marks, student 2 and 3 will be having same marks. Let's sort them first. Since student 2 and 3 have same score, which is 85, they come at position 3rd and 4th, and Excel keeps them in the same order as before. But if you want to give another rule, that is, if you want to say that this should be first sorted basis math score and then by science score, you can do this by using custom sort. Go to sort and filter, select custom sort. First tell it to sort by math score, which is already there. Then add a level, select science, and then in descending order, largest to smallest, click on OK. You can see that student 2 is now in 4th position below student 3 because of lesser marks in science. Next we look at the filtering options. Filters will allow you to keep and filter out the data you desire. That is, if you have data of both male and female and we want to look at the data of females only, you can put a filter on gender and select females only. In our example, we first select the table on which we want to apply filters. Now you can either go to sort and filter and select filter option, or we can just use the shortcut Alt then A then T. You need not press them simultaneously, just in order Alt A T. You see these small triangles, clicking which will give us options. In options you can see that we can also sort the table from here also. Now to simply put a filter, you can go and select or deselect the numbers shown below. So if we want to keep only 99 and 100 scored student, we deselect all the other options and click on OK. Only these two students remain. All the other 3 rows are now hidden. You can also use the search option. If you have a large data, you can search the particular value and click on OK to keep that particular filter. One thing we can observe is if we apply a filter of say 99 and 100, you can see that small triangle has changed to a filter symbol. This tells us that which column has actually filter applied on it. Another thing to observe is if the column has numbers, the option when you click the small triangle says number filters, and if the column contains text, the option says text filters. So let us first go through the number filters. We select the small triangle on maths marks. There are several number filters available. These are self-explanatory. You can either specify a number which equals the data or does not equal the data, or you can specify a number for which the data should be greater than that particular number or less than that particular number. For our example, we will use the greater than filter. Let us click on greater than. Maths is greater than 80. What this will do is it will keep the data only of students who have actually scored more than 80 marks. Similarly, we can look at the text filters. In text filters, we have fewer options which say equals or does not equal, where we can give a particular string and it will match if that string is exactly same in our data set. The other option is begins with or ends with, where it will just check that the data in the column actually begins with the string that we have provided. Similarly, there is a contains option which says that all those rows of data will remain which contain the string that we have provided. I will suggest you to explore these on your own. If the column contains both numbers and alphabets, custom sort filter can be used, as it shows both options of text filters as well as number filters. For now, let us just put a custom filter on maths marks only. Let us go to custom filter, and first we will put a greater than filter of 75 marks and a filter of less than 90 marks. So only one student who has actually scored between 75 and 90 is remaining in this data. Other students have been hidden. Next up is data validations. Data validation is used to prevent wrong inputs during data entry. Suppose we float a sheet to gather customer or student data. We want certain validations such as phone number field should contain only numbers, date of birth should not be older than 1920, etc. So how to apply such validations? First, select the cell on which you want to add validation. So if we are adding a new subject scores here, we want these cells to have numerical values between 0 and 100. So select these cells, go to data, click on data validation. In the allow drop down option, select whole number and mention minimum as 0 and maximum value is 100. Click on OK. Now whenever we will try adding a larger number, it will give us some error message. Let us see. Excel is giving us this error which says this value does not match the data validation restrictions defined for this cell. If we retry and enter a genuine number, that will be allowed. Similarly, for the name of subject, if we have a fixed list of subjects, we can give a list validation. To do this, go to that particular cell and click on data validation. Now in allow, select list. In the source option, you can either mention all the subject list comma separated, or you can go and select the list in the Excel sheet that I have created. Click on OK. Now you can see a small drop down option in this particular cell. If you click this option, you can see all the subjects as a drop down. You cannot enter any other value for this cell. Only this drop down value can be selected for this cell. Another check that can be applied is on the length of input characters. For example, if the student name cannot be more than 10 characters, we go to this cell, go to data validation, allow text length and a maximum value of 10 characters. Okay. So now if we try to enter 11 characters, it will give us this error prompt. In the data validation options, two other tabs are also available. These are the input message and error alert tabs. Input message will be displayed when the user is inputting the data, and error alert comes up when user has already broken the rule that we have defined. Let us customize these two messages and see. For input message, we give a title of and for error alert, Title will be error in data entry and message will be please enter score between 0 and 100. You can choose the icon that you want to get in the error message. I'll use the warning sign. Okay. Now in this cell you see that whenever this cell is selected, the input message will be shown, and whenever you break the rule, so probably I forgot to mention the rule. Let's go and mention the rule first. Allow whole number between 0 and 100. Let's check if the input message is still there. Yes, error alert is still there. Okay. Now let us enter 110. Enter. This is the custom message that we told it to show. Error in data entry. Please enter score between 0 and 100. Next is text to columns. A lot of times we get comma separated or tab separated data or just join data without any spaces. Since keeping data like this takes up less space, the file size is small and there is no limit on file size also. But when you are working on it in Excel, you want different parts of data in different columns so that you are able to work on it. Excel helps you move this text in table format. Let us see how. For student 6 data in our notepad file, we can see that the data is comma separated. If we copy paste this data in our Excel sheet, this comes in one single cell. To move this data into the right cells, select this cell and go to data, select text to columns. You can see two options here. Delimited is where data is separated by a particular separator such as comma here. Fixed width is used where there is no separator but we know exactly the number of characters that each column should contain. So here we will use delimited option. Select comma. You can see the separating lines that Excel has created for us to preview. Click next. Click on finish. You can see that the data is now in the correct cells. Let us do the same for other students also. So again for student 7, data is separated by a star symbol. Now we again go to text to columns option, delimited, next, others, specify the separator which is star, next, finish. Okay, this is also done. Similarly for the other two students, there is no particular separator but we know the column length for each set of data. Let us see how. Text to columns, fixed width, next. You can add or remove these separating lines. To add a line, click at the desired position. You can delete a line by double clicking on it. You can drag and drop a particular line to move it. Click on next. OK. Data is now in the respective cells. This was text to columns. Next is the option of removing duplicates from data. So many times the data has same entries several times. We may want to remove these same entries. In our data, we can see that student 2 has 2 entries, student 5 has 2 entries and student 3 also has 2 entries. Some of these entries are exactly same. For example, student 2, the maths and marks is science and English, all three are same in both the entries. So we may want to remove such duplicates. Let us do this. We first select the data, go to data and select remove duplicates. One thing to note here is there is a checkbox which says my data has headers. Since our data has the heading of students, maths, science, and English, we have ticked this option. In case there is no header in our data, we can untick this option. So to remove exact duplicates, for example, the student 2 that we discussed, which has same marks in maths, science, and English, we will select all the columns and click on OK. We see that 2 duplicates have been removed and 6 unique values remain. Still, student 5 has 2 values. For student 5, we want to keep only that entry in which student has scored more marks in English. So let us select the table again and we will sort this data by the marks in English from largest to smallest. Now we will remove the duplicates in this data. This will remove the second entry of student 5 which has lesser marks in English. So uncheck all the other columns, just keep student name and click on OK. That one duplicate value of student 5 has been removed and you see that the one with lesser marks in English has been removed and the other entry still stays. That's all for this lecture. In next lecture we will learn about formatting options in Excel. Thanks. Hi everyone. In this lecture we will learn what all formatting can be done to make our data look good. Here is our sample table where no formatting has been done. Data in this format is not very appealing and you should not show such data in your presentations. Let's try to learn the tools which make data beautiful. Let's first highlight the header of our data table. We'll select the cells which have the headers and we'll click on the B icon which bolds the text that we have selected. You can see the weights of the text in this selected area has been increased. You can compare student with the student 1 written below. Now we will select the student 1 and other student names from the data and make them into italics. We will click on the I icon and you can see that all the student names have been changed to italics. Now we will bold the average written in the 14th row, but to do that, instead of selecting all these and clicking on bold icon, we will select the first row, which is our header row, and click on Format Painter. What this does is, it copies all the formatting of the selected cells, and when we click on the other cells that we want to format, it copies that formatting on the destination cells. As we can see, average is now also in bold format. Next, what we will do is we will underline the total and percentage headers. So we select those two cells and click on underline. You can see that these two headers are now underlined. Now we will change the format for this table. We'll select the whole table, go to the drop down option where Calibri is written, and we will select Century Gothic font for our table. You can see the numbers in this font are much bigger and much clearer. Next, what we will do is we will see how to increase font of the text. We will select the header and we'll increase the font by clicking on this capital A icon, or we can just go to the numerical value of that font size and change it to 13. You can see that header font size is increased. We can also decrease the font size for the rest of our data to 10. Next, we will apply border to our table. Borders give clarity to the data set that we have. It clearly demarcates the data from rest of the worksheet. We select the data, go to this icon, click on it and select draw outside borders. If we unselect the data, we can see that there's a small box which is containing our data right now. Within our table, if we want to have different kind of separating lines, we can again select the data, go to that icon and select more borders. Here you can select the style of line that you want to include, and then in the right side where a graphic box visible, you can click and add borders. This represents that we have added a dotted separating line within our data, and outside there is a solid box. If you click on OK, you can see that the within our table there are dotted lines, and outside the table there is a solid box. Next, we will change the color of our header cells. We will select the header cells, go to cell color option, and we will give it a light gray color. Next, we will change the color of student names to light blue. We can see that some of the students' name are not visible because of limited space in the column A. So now we will learn how to increase and decrease the column width and row height. First of all, we'll double click on the separator between A and B column. This will automatically increase the width of column A to fit all the text in column A. To do this for all the rows and columns, select the whole table, go to the format option and select auto fit column width. We can see that it has fit all the data in each column basis the maximum characters in that column. We can see that total column is now very small, whereas the percentage column is very large. To manually correct this, you can go to the separator between H and I to increase this, or you can also go to the format option and specify column width for this column. Similarly, height of row can also be increased or decreased. So for average row, we will increase the row width slightly. Next thing that we will do is we'll align our text. So we will first select all the headers that we have and align them centrally. Right now, if you can see the total column, the total is written on the left hand side. This is because it is left aligned. If we align it centrally, total will move to center. Now we will select student names and we will align them to the right. For the last row, which contains average, we can align text vertically also. So to align this in the vertically central position, click on this icon, which is called middle align. You can align text in top and bottom alignment also. To add a title to our table, we'll add first few rows on the top of this table and one column on the left of this table. One shortcut to note here is once we have added a row, to repeat that action, you can use a shortcut which is to tap F4 key. Whenever you tap the F4 key, Excel will repeat the last action. Now let us first write the title of this table, which is same as the title of this lecture, data formatting. And this table contains student data of class 12. Now you can see that the B3 cell, it has more characters that can fit into the column width. That is why the text in that cell is going over into the next cell. To avoid that, we can use the wrap text option. When we click on wrap text, the data within that cell moves into the next line within that cell. If we add more text to that column, it will automatically adjust and increase the height of that row to accommodate the added text. Another option to accommodate when there is more text than the column width is the merge and center. So we unwrap that text that we wrapped earlier and let us select all the cells till the width of this table. Now let us merge and center these all cells. You can see what happens is all the cells from B to J column have been merged into a single cell, and the data entered in B cell is now present in this merge cell. Also, what happened was after merge and center, the data was present in the centrally aligned position. We clicked on left align to left align this data. You can keep it centrally aligned if you like it that way. Now let us move to the percentage column. This column right now has fractions which has been calculated by dividing total marks scored by each student with the maximum marks that can be scored in all these 6 subjects. To convert this fraction into percentages, we select all these and click on the percentage icon above. You can see that all these fractions have now been converted to percentages. Another thing that we would like to do is in the last row, which is the average row, we can see that there are a lot of decimal points. These numbers after the decimal points may not be relevant to us. We may just want to look at average till one decimal value. Let's select all these and go to the reduce decimal values. Click on it several times till it is one decimal value only. So now let us move on to conditional formatting. Conditional formatting is a very strong tool that Excel provides us. This tool provides us the option to visually highlight the data as per the rules that we have specified. This makes the data more understandable just by looking at it. So let us highlight in our example those students who have scored less than 35 marks in any of the subject. So we select all the numbers. Then we go to conditional formatting and go to highlight cell rules, select less than value, give a value of 35. You can select several options here. We will be selecting light red filled with dark red text. You can see that 4 cells have been highlighted. For student 2 who has scored less than 35 marks in history, student 5, and there are 2 other failing students in history. All these have been highlighted. Had this option not been available, you would have to manually find all these individual cells and highlight them using the cell color option. There are other options in conditional formatting also. So let us select the total column and let us look at what other options are available. So if we go to the top bottom rules, you can highlight the top 10% students basis their total marks. We will change the color to green and select top 15% students. So student 4 with maximum marks has been highlighted, who has scored 522 out of 600. Other options available in conditional formatting are, so we select the percentage column and we go to data bars. It will not be easy to visualize on the percentage column. Let's go to the maths column. and go to conditional formatting, data bars, you can see that each cell is filled up to the position of value that they contain. So 100 is 100% filled, 99 is 99% filled, 45 is 45% filled. Similarly, now we will select the science marks to look at other options. We go to color scales. If we hover over one of the options, you can see that the colors are highlighted basis their values. So the highest is, so in this example, highest is marked in dark green and the lowest is marked in red, and different set of values have been highlighted in different set of colors. Next we look at the icon sets. We select the music scores, go to conditional formatting and look at icon sets. If we go to the directional arrows, they will separate the data set into three parts. The top percentile will have upper arrow, the middle percentile will be marked with yellow horizontal arrow, and the last percentile will be marked with red arrows. On the percentage column, we will try to now apply a custom rule. So we go to conditional formatting, apply new rule. We will select a two color scale where lowest value will be light green and highest value will be dark green. Okay. So just by looking at the data, you can see that student 1 and student 4 have probably the highest percentages, and student 2, student 5 will be having the lowest of percentages. Next, we look at some of the options available in the view menu. In view menu, you can see that there are four checkboxes. One is grayed out. There is one option of grid lines. If you uncheck it, you'll see that the grid lines around the table have been removed. This particularly highlights the data table and the cells that contain the data. All the other cells, the boundary for those cells have been removed. If you uncheck the formula bar will not be visible to us, but we'll like to see the formula bar, so we'll check it. If we uncheck the headings option, we'll see that the column names and row numbers have been removed, but we'll keep that also. There is a zoom option also, but instead of using that, I'll suggest that we should use zoom in and zoom out from the bottom right corner. Next, we will look at an important tool which is freeze panes. Freeze panes gives us three options, which are we can freeze the top row or the first column or the customized row and column that we want to freeze. What freezing a row or a column does is, whenever you scroll down, we are not able to see the table headers for the rest of the data. Similarly, if we scroll to the right, we will not be able to see the student name if there are a lot of columns in between. So what we can do is we will use freeze panes and we will use the first option. To use this, select the cell whose top row and left column you want to freeze. Select that cell, go to freeze panes and click on freeze panes. You can see there are suggestive lines which say that the top part of that line has been frozen and the left part of that line has been frozen. Now if you move your cursor below, the top pane is not moving, all the table is going under it, and if you move it to the right, the left part is not moving, the other part is moving under it. So when you have a large set of data, to maintain the table headers and table first column, you can use freeze panes. That's all for this lecture. In the next lecture, we will be discussing about pivot tables. Thanks. Hello everyone, welcome to this lecture on pivot tables in Excel. Pivot tables are very strong tools which are used to summarize large data sets. Pivot tables automatically group together similar variables to give out a meaningful summary. To understand how, let us look at this furniture sales data for Solid Woodworks company. In the first column, we have salesperson name. I have kept them as salesperson 1, 2 and 3 and so on. Then is the product sold name. The next column contains region in which the sale was made. Next is customer name, then date, then number of units bought by the customer, then is the per unit cost, and the next one is total payment made by the customer. Now let us say we want to find out the sales made by each salesperson. One way to do this is to apply filter one by one and sum the sales by each salesperson. So we have applied a filter on salesperson 1 and the sum of sales is about 2 million. But doing this will be very time taking and cumbersome. Instead, let's do this using pivot tables. So we go to the insert menu, click on pivot table. In the first text bar, please ensure that the entire table area is selected, which Excel has selected automatically for our case. Next, if you want the pivot table in the same worksheet, select the same worksheet option. I want it in the new worksheet. So select OK. You can see that a new sheet is added to the file. On the right is the pivot table menu. Notice that it has all the column names listed. Below this list are 4 small boxes. We can just drag and drop the desired column from above in the respective box to get our customized report. If I drag drop salesperson in the rows, all the salesperson are listed on the left. Similarly, if I drag and drop the region name to columns, all 4 regions will be listed in columns. We can apply filters by using the filter box. But now let us try to get the sales summary of every salesperson. We will drag and drop the salesperson in the rows box. Then we will drag drop total sales value in the values box. Notice that this is showing sum of total cost in the values box, which means it has automatically added the sales value wherever salesperson was salesperson 1 or salesperson 2 and so on. Next, to identify which customer this salesperson has sold how much amount of furniture, we will pick up customer name and will drop it into the columns box. We can see each salesperson sale to each customer and the value of it. But if we want to see the count of sales that each salesperson has done, we will go to the values box, click on value field settings, and instead of sum we will select count. Click on OK. You will see that salesperson 1 has made 17 sales to furniture and 11 sales to renticle. Overall, as per the count, salesperson 12 has made 119 sales, which is the largest sales. To arrange this data, that is to sort this data from largest to smallest, you go to the grand total column, right click on any value and select sort largest to smallest. You can see that salesperson 12 is now on top with the maximum number of sales and salesperson 7 is at the bottom with the least number of sales. There is one more box left, which is the filters box. If you want to apply some filter, say for example, if I want to filter out some particular regions from my data, I'll pick the regions box, regions options and put it into the filters box. You can see that it has come on the top left corner. If you click on the small triangle, you see all the 4 regions that our data has. If you select northeast only and click on OK, these 4 salesperson have made these many sales in the northeast region. Similarly, you can change northeast to northwest to see the sales in northwest region. But if you want to select multiple values in this filter, tick on this checkbox and then select multiple values that you want to filter. So if we want northeast, northwest and southeast, tick those and click on OK, and we will find all the salespersons who have sold in these three regions. Now, instead of seeing this data from salesperson point of view, if you want to see the amount of sale made in every month, we will remove salesperson from this table and we will bring the date column inside the rows box. We can see that the dates have been grouped automatically by Excel into years, quarters and dates. If you want to change the grouping, you just go and right click on it, go to the group option and you unselect years and quarters, leave the months option and click on OK. You will now be able to see monthly sales for this furniture company. Next, if you want to merge the total sales made to these two companies, which is Home Space and Hometown, probably these two companies have merged together and we want to group these two sales values, we'll select these two and right click, group, and when we click this minus button, we will see the combined sales to this group of two companies. Next is the slicer options. Slicers are similar to filters, only these are more convenient to apply. So to apply a slicer, we go to the analyze option in the menu and in that we go to the insert slicer option. Insert slicer is giving us the option to select the column name on which we want to apply this filter. So for example, if I want to apply a filter on region, we will tick on region and click OK. So this slicer has the four options which our filter also had. If we click on northeast, we are seeing the sales in northeast region only. If we click on northwest, we are seeing the sales in northwest region only. If I want to select multiple regions, I'll click on this button and select northeast and northwest both. So this gives us an easy way to apply filters. That's all for this lecture. In the next lecture, we will cover charts. Thanks. We usually create charts to make a point or communicate a specific message. Sometimes we need charts just to provide a visual support for our claims. For example, you will find people saying the sales are increasing at 10% along with a bar chart, or that the jobs in analytics industry are exploding while using charts to compare different fields. You must have heard people communicating these kinds of messages using charts. The important point here is that there should be a message from your chart. Without a message, your chart will just be a picture dumped into a presentation slide. And in today's world, with abundance of easy techniques to create charts, we are encountering more cases of random irrelevant data just dumped into charts without any message or relevant outcome. After completing this course, I am sure that you will be able to avoid such instances and will be able to point out random data dumps from the impactful and meaningful graphs. So let's start with our topic of communicating a message from a chart. We first need to assign a category to the message that we are going to communicate out of several categories that we have. And later on in this course, we will learn how to choose the best chart type depending on the underlying message category. So let's look at the categories first. The first category is when we want to compare one item to another item. For example, a chart may compare sales in each of the company's sales regions. So we may want to compare the sales performance in the north region versus the south region. Second is comparing data over time. For example, a chart may display sales by months and indicate the trends over time. Third is making relative comparisons. An example of this is a common pie chart which we see during election results. The pie charts display the percentage of votes or the seats won by the different parties in the election scenario. The fourth type of message is comparing data relationships. We may want to explore the relationship between two variables. A common example of relationship between variables is marketing expenditure versus sales. So you may want to see if increasing the marketing expenditure is increasing your sales or not. The fifth category is frequency comparisons. A common example of frequency comparison can be a histogram displaying how many students have scored between 80 to 100, how many have scored between 60 to 80, and how many of them have scored below 60. The last category that we are going to talk about is identifying outliers and unusual situations. If you have thousands of data points, creating a chart may help identify those data points which are not representative. That is, data points which are misrecorded or miscalculated or having some issue with them. For example, if you are manufacturing tennis balls of certain radius, you can plot the radius of all the manufactured balls over a chart to easily find out the wrongly manufactured balls which are having different dimensions. I hope with this you will be able to assign your message to one of these categories. Take some time to identify the last chart that you drew in your job and try to assign the message that you communicated in that chart into one of these categories. Think about it for next 5 seconds. In the next lecture, we will look at different elements of charts so that we can start our journey of different chart types. Congratulations! You have crossed the final milestone. You have completed this entire course. You should be proud of yourself because out of all the people who enroll in the course, only 5% reach this point. So you are among the top 5% students of this course. After the next lecture, you will receive your certificate of completion in your registered email ID. If you do not find it there, you can download the certificate from here. And if this button is grayed out like it is grayed out right now, then you must have missed some lectures in between. You can check the missing lectures from this right panel. You can also manually mark lectures as complete from here. Once all the lectures have this tick mark in front of them, you will be able to download the certificate. If still you are not able to download the certificate, you can contact Udemy customer support for this technical issue. Also, I would like to request you to rate this course and write a review, because a review from a sincere student like you will motivate us and it will motivate other students to continue their learning. Once again, congratulations and keep up the good work.